Okay, here are the notes from section 2.7. And we were trying to solve an equation, fractional equation with rational fractions with all kinds of polynomials, top and bottom. And you just need to clear out the fractions by multiplying both sides by every factor that's in every denominator. In this case, we have an x minus 1 and x minus 3, and after you factor this, an x minus 3 and x minus 1, so multiplying both sides by x minus 3, x minus 1 will take care of clearing everything out. When you multiply x minus 3 times x minus 1 times this fraction, it looks like this, and you'd have the x minus 1's canceling, left with 2x times x minus 3, which we put here, and then take this times 1 over x minus 3, and the x minus 3's cancel, you're left with 1 times x minus 1, and on the right side, both of the factors in the denominator cancel, and you're left with just a 2. You distribute this all out. 2x squared times x, 2x times 3 is negative 6x, and x minus 1, 2, you combine like terms, 2x squared minus 5x minus 3, factor it, and you get x equals negative a half, or x equals 3. But x minus 3 is an extraneous solution. It does not work because if you put a 3 in, it will make the denominator 0, so we will get rid of that one, and the only solution is x equals negative a half. The next problem is number 2. We will solve, I want you to solve it both algebraically and graphically. So on this problem, we will multiply both sides by x minus 4 to get rid of this denominator, and you get x times x minus 4 plus 1 equals 0. Distribute, and you get x squared minus 4x plus 1 equals 0. That does not factor, so we go to the quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac all over 2a reduces to 4 plus radical 12 over 2. 4 times 3 is 12, so we got radical 4 is 2, so it's 4 plus or minus 2 radical 3 over 2. And reducing that down, dividing 2 into both 4 and 2, you get 2 plus or minus radical 3. So my two solutions are 2 plus radical 3 and 2 minus radical 3. Now, they wanted you to also do this graphically. Well, I'm not sure you can do that by hand very well, but let's take a look at it here on the graphing calculator. And as you can see, this is what I had to change my window so I could see it. I went with that window. And in the graph, if I hit trace and I type in 3, I'm sorry, it was 2 plus radical 3. So if I type in 2 plus radical 3 and hit enter, it shows me one of the zeros, and 2 minus radical 3, and it shows me the other 0. And you could do a second do a second calc to find those, but we already found them, so we just verified that they were the solutions. So we move on now to number 3, and here we're going to again clear out the fractions, multiplying by x plus 3, x minus 3, and when you do that, you can clear out the x minus 3. It's going to be 6x plus 3. Both cancel here, 8x squared. The x plus 3's cancel here. You get negative 4x times x minus 3. And distributing all this out and bringing everything over to this side, combining like terms, you get 4x squared plus 6x minus 18. Divide everything by 2 both sides, and then you can factor easily, and you get 2x minus 3, x plus 3, so you get x equals 3 halves, and x equals negative 3 again, but once again, negative 3 will cause you to put a 0 in the denominator here and here, so therefore it's also extraneous, and the only solution is x equals 3 halves. The last problem is a mixture problem. We've done these before. How much pure acid, so that's 100% acid, and how much we don't know, so we call it x milliliters. And we're going to add 35% acid, 50 milliliters of 35% acid to that. We're going to get 70, and we want a 75% mixture of 75% acid mixture, and that's going to have a total of x plus 50 milliliters in it. So then we say the amount of acid here plus the amount of acid here should equal the amount of acid in the mixture. So 1x, 100% of x, that's all acid. 35% of the 50 milliliters is acid. 75% of the x plus 50 milliliters will be acid. We multiply 0.35 times 50, get 17.5. 0.75 x and 0.75 times 50 is 37.5. Bring 17.5 over 0.25 and bring the whoa, this is not correct, is it? Yes, it is. My bad. We're going to subtract 0.75x from 1x and get 0.25x. We're going to subtract 17.5 from 37.5 and get 20. And then when you divide,